Hello friends, welcome back. In today's video, I'd like to talk about functions as power series. So we spent the last two videos introducing power series and discussing the radius of convergence and the interval of convergence. Now we would like to make a switch in our unit. So we're going to be moving from actually the super abstract parts of series and power series, moving into the applications. Now, one of the applications of power series is we can represent functions with power series. So we're going to discuss how to do that in this video. Let's get started. So there's one general form for a series that we want to discuss, and this will build a basis until we learn some other methods on how power series really work for algebraic systems. So this is a super important series for power series. For power series, this is actually the one series that we need to remember because everything else branches out from this one. So if I take the sum over x to the nth power from 0 to infinity, and I've got 1 plus x squared or 1 plus x squared, and we go all the way out to 1 plus x to the n. What ends up happening is we can assert that x is going to be a fraction of some sort, so that our series converges, and then when our series converges, we can just use the geometric series formula. It gives us 1 over 1 minus x. So that's really important because this asserts that we have a function that we know a series represents. So we know that we can represent this expression with this function. So let's try an example of representing a function with a power series. So let's say I want to represent f of x with power series, and f of x is 1 over x squared plus 1. Okay, so 1 over x squared plus 1, well, it looks a little bit like this. The basic idea when we're doing these calculations, so we want to make this function some form of this. Obviously, this can get rather tricky, but the algebra is something that you probably learned earlier, so we don't need to do super complicated examples just to get the idea down. So what we're going to do is we're going to mold this so that we get something like 1 over 1 minus u. And then we can get the sum from n equals 0 to infinity of u to the nth power. So we'll get something like that. So what we're going to do is we are going to reformulate this. So 1 over x squared plus 1, we can rewrite this as 1 minus negative x squared. We can write this as the sum from n equals 0 to infinity of negative x squared to the nth power. So what do we do from here? Well, now we can actually generate a more kind-looking series so we can find our radius and interval of convergence. So we get this series here, the sum from n equals 0 to infinity of negative 1 to the nx to the 2n. Okay, well, this is a geometric series as well. So what we can do is we can assert that x is going to be between negative 1 and 1. So that's how representing a function with a power series works. Basically, you take your function. These will be algebraic for now. We want to transfer these into something that looks like 1 over 1 minus u, so that we can plug it into this formula. This is basically the idea of how to represent the function with the power series, and then you can do this. And you can use techniques. If I want to find f of a, well, then that's just the sum n equals 0 to infinity of a to the n, which we can calculate using the geometric series sum formula. So in the next video, we're going to be actually talking about if we can represent functions like this. Well, the next logical step in a calculus class is how we can represent derivatives and integrals with these series as well. So we're going to look at that in the next video. Thanks for watching. We'll see you then.